Hello guys, welcome to Impact. So we have been looking at certain current affairs, some current affairs videos. So in this lecture or in this small video, we will look at a topic called solar geoengineering. So why we are looking at this topic? Because it was in the news yesterday. So climate change is becoming important day by day, both from the common man's point of view and especially important from UPSC's point of view. It is being continuously asked in preliminary and mains areas. So this particular topic, this particular area is one way of fighting climate change. Again, this we will see, look at the different methods. This method has not been tried at a very large scale so far. Some of the methods in under this broad head, they are still experimental. It has not yet proven because we still do not know what will happen or what might happen as a consequence of this. Today we are mainly fighting climate change by reducing our fossil fuel emissions, by planting more trees and various other carbon capture technologies, by adopting blue hydrogen, etc., blue hydrogen, green hydrogen, etc. So here we look at only this particular method of fighting climate change. Again, it is not a method for adaptation, it is a method for mitigation. So it is an interesting area. So here we are going to discuss three techniques of solar geoengineering. So one is stratospheric aerosol injection, then natural aerosol, and marine cloud brightening. So what is the overall concept behind it? You must be well aware of what is greenhouse gas. So we have sun's rays that are coming in. It hits the surface, then surface becomes warm, then the air above becomes warm. Now what we are doing, we are increasing. Not all gases absorb this heat. There are only certain type of gases called greenhouse gases, CO2, which is very important. Greenhouse gas, H2O, it is the largest greenhouse gas. Then methane, etc. They have the unique capacity to adopt or hold more of this heat. Hence, they are all called greenhouse gases. So as a result of fossil fuel emission, what we are doing, we are increasing the quantity of this by a very large extent. Now, as we increase, the surface temperature, the more and more heat is getting trapped and the more and more temperature is increasing. So we can see 2015, 16, 17, 18 has been some of the hottest years, and every year average temperature has been going on and increasing. So what is this geoengineering technique, solar geoengineering techniques? How can we reduce climate change or at least mitigate climate change? So what they plan or where they plan the intervention is, see, what if, let us say 100 units of solar radiation is coming. What if we are able to reflect, let us say 5 units, 3 units before even it hits the ground, before even it hits the atmosphere? Yes, some part is absorbed by the atmosphere, but the major part of heating happens only after it hits the surface. The surface becomes warm, then the gases above becomes warm, and then it goes on and goes on. So here, now how can we make sure here itself some solar rays are reflecting? So one, simply place a very big mirror. Now this mirror would be very, very big. It might appear foolish to some people. Is this even possible? Some might be thinking, is this even possible? But yes, this has been thought of and it has been deemed technically possible. But so far, nowhere it has been carried out. Now, some other things which can serve a similar purpose is one is stratospheric aerosol injection. So stratosphere, we know, lower layer is troposphere, around 10 kilometers thick or 10 to 18 kilometers, depends on where it is, whether you're located at the equator or you're located at the pole or some other latitude. Above it, we have stratosphere, which goes on up to 50 kilometers. So in this layer, why not have aerosols? So what are these aerosols? They are very tiny particles. Now, what is the good part of what is this property? This aerosol has a capacity to reflect the sun's rays. So here, now when we are increasing the aerosol here, if before even it comes and hits the surface, it will be reflected up. So if you are putting it at a very, very large quantity, yes, we can reflect significant percentage of it. Now this, what we are discussing is an artificial method. This we have done, what if we will be doing, we are inserting it artificially. Now what about the natural aerosol method? In this natural method, let us say we have volcanoes. Now volcanic eruption will naturally emit a lot of aerosols. So, and if the volcanic eruption is powerful enough, it will be thrown into the upper atmosphere and it will be rotating. Now, it has been proved scientifically that volcanic eruption, a major volcanic eruption, which has thrown a lot of aerosols, has led to decrease in average temperature, at least in one particular region, if not globally. So, in case we are having a natural volcanic eruption of very large scale, or let's say we are inducing something of that scale, then again, we'll have, it will be covered, so upper atmosphere will be covered with aerosols over a large area. It will again reflect up. What is the one other way that we can try? Marine cloud brightening. So here, here the technique is to spray sea salt into low-lying clouds so that it increases the brightness, and when its brightness increases, it will be able to reflect more and more emissions. So these are some of the three methods that was discussed in news, or that are again part of solar geoengineering. It is not that there are only these methods. Like I said, placing a huge mirror in space, that is also one other method. There are several other methods also, but here in this video we are sticking with what has been discussed only in the current affairs in the paper. So that's all for this video. So questions can come on what is solar geoengineering, or marine cloud brightening recently seen in the news is related to what? What is can volcanic eruptions cause climate change? So on questions can be asked based on this lines in prelims. In mains, they can simply ask what are the various solar geoengineering methods to fight climate change. So that's all for this video, guys. Thank you.